reach 5 to 10 people by 6:10, we can start.
See.
Just so or 6:10. Why is he saying 6:10?
7:10.
7:10.
Yeah. All right.
Yeah. Let me bump everyone.
Hey guys.
I just added everyone. I have the power to add everyone.
All right.
We'll start. Say that we'll
Seven.
start 7.
7:10. We'll start 7:10. All right. Have you used Lucid Chart?
You should try it.
Have you used
Or
Lucid?
Lucid. I don't use Lucid.
Say removed Jamboard. It's like, oh, okay.
Oh, this is the new Jamboard.
Yeah. Google doesn't support
Mm,
Jamboard anymore.
yeah, I
So
know.
I'm using Lucid.
Is it at
It
least
seems
half as
nice.
good?
It
Okay.
seems nice because can you can add like different frames and then
Oh, it's not
maybe
just one. It's like Jamboard
yeah,
then.
it's like Jamboard whiteboard, and if you can frame 2, frame 3, right? That's cool. I like it. Looks cool. Um, delete.
Yeah, that's a good sign.
Voting. Hey guys, let's do a poll. Oh, never mind. Premium. Let's do it. All of us are premiums.
I don't. That's not. That's not. Oh wait, I should send the link to the channel. As well for those if people come here, or should I do that later to incentivize people to go? Just wait until sometime. What do you think? Do I send the link to the stream now or later? The stream. But you can just say like I joined the Discord or okay, I'll meet when I'm gonna eat. Heinrich, you should meet when I'm waiting. Oh, that's it. Hello. Hello. You guys do? Hello. No one's joined yet. 3 minutes. 3 minutes. Yeah, no worries. Responsive naman yung mga tao. So it's alright. Just wait for them. I'm just dropping by kasi na-move yung interview ko. Push back siya by like 30 minutes. But I'll get off the call in the middle of it. But yeah, just message if you guys need anything. Alright.
Hello guys, 7:50 now, so let's just start. Today, this is the Math 22 review for LE2, all about sequences and series and finding their convergences. Before we start, I'll share with you two links. I'll in the Discord chat. Alright. So I sent two links in the Discord chat. The first one is the Lucid link, so if you want to watch in, join in. And the second one is just a summary of all of the convergence tests I found. So it's very informative, it's very specific, and so it's a very useful thing to just have as a cheat sheet. Alright, let's just start now. So determine whether 5n minus cos 1 over n is convergent or divergent. So first of all, the difference between a sequence and a series is that a sequence is a list of numbers, while a series is the sum of each of those numbers in that sequence. Right? And another one is, just so that we're all on the same page, convergent and divergent. Convergent means that as n approaches infinity, as n approaches infinity, it approaches a specific number. So, for example, for number one, determine whether this function is convergent or divergent. So the way we do it is, we find the limit as n approaches infinity of this function, of this sequence. Right? So I'll just find n is cosine 1 over n. Right? This one is just very simple, so it's just 5 over infinity minus cosine 1 over infinity equals to 0 minus cosine 0, which is equal to negative 1. So what this means is that as n approaches infinity of this sequence, the theoretical last number of this sequence is negative 1. So since it's not infinity, not negative infinity, we can say that this sequence is convergent. So, is convergent. Convergent. Alright. So this sequence is convergent. Okay. So for number 2, it's the same function, but now it is looking for whether the series is convergent or divergent. So, so whether the series is convergent or divergent. So we do the exact same. Steps. We find the limit. It's just the same thing. So limit as n approaches infinity. As the limit approaches infinity, we know that this is equal to negative 1. But since this is a series now, and since you're adding each and every term in the sequence, even as n approaches infinity, since it is not equal to 0, that means there is no last number if you add every single digit, because it will be at the very end, it'll be like negative 1 plus negative 1 plus negative 1. So since it's not equal to 0, that means the series does not stop, and that means this is divergent. Here. Alright. So now for number 3. For number 3, consider function f of x equals 1 over x fourth root of ln 5x. That is continuous positive value and decreasing on 3 positive infinity. Alright. So this is already a hint, I'm pretty sure. I know, but this a hint is if it says it's continuous, positive, valued, and decreasing. If it says that, we can use okay, we can use the integral test. So the integral test is it basically says that if you find the integral of this function, whatever that integral is the sum of f of m. The sum of the the series of f of m. But the requirements of doing the integral test is it's continuous, it's positive valued, and it's decreasing. Also, something to note is that you should use the integral test if the function itself is very easily to integrate. So, for example, this one, 1 over x, let's say ln 5 over 4 here. So it's there. We use u sub. We're trying to integrate this from 3 to infinity because it says right here 3 to positive infinity here. So let u equals ln x du equals 1 over x. Um, Integrating this, it becomes du over u 5 over 4, 5 over 4, yeah, 5 over 4, integrate 3 infinity. Sorry. 3 infinity u negative 5 4 du equals to negative 4 over u 1 fourth 3 infinity. Right. And now and for this one, remember to have the bounds, and then we integrate it by the bounds as well. So it's a definite integral. So negative 4 over u 1 fourth, u 1 fourth is ln x, ln 4, ln x. So this is equal to, I just simplified it already, 0 minus negative 4 over 4th root of ln 3. So it's equal negative a positive 4 over 4 ln 3. And with this, we know that it is convergent, right? Because the way the integral test is, whatever the final thing you get for the integral test is already the the total sum of the series already. So if this is a positive real, not positive, if it's a real number, then it is convergent. Yeah, it's convergent. All right. So now for this one, with this, something we can do here is that we can try. We will be using something called. We'll be using the LCT, the limit comparison test. And the way the limit comparison test works is that the function that we have here is equal to a sub n, and we have to find a b sub n that when we do an a sub n over b sub n, the final the final they should be equal. They should be equated to a positive real number. And if it's a positive real number, then whatever b sub n is equal. So if b sub n is convergent or divergent, a sub n is convergent or divergent. Yes. All right. Yeah. If it's a positive real number, a sub n, b sub n, a sub n is the same converging or diverging as b sub n. So something we can do here is that we can try to make these two things have the same power. Right? So if we simplify this is just 4n plus 3. Oh, wait, no. This is basically equal to 4n 1 half over n squared. So something we can do here is make our b sub n equal to n 3 halves, 1 over n 3 halves, 1 over n 3 halves. So, so when we a sub n b sub n over here, it will be equal, it will be this. So our a sub n b sub n here will become square root of 4n plus 3 over n squared plus 5 times, as this is b sub n is 1 over n 3 halves, so a sub n over b sub n, it will simplify into just n 3 halves here over 1. And we can simplify this equal to 4n 4 plus 3n 3 all over n squared plus 5. And with this, we can just use I'll do it outside the frame. That's 1 over square root of n over 4 over 1 over square root of n 4. Plus with that, equate it here. It becomes 4 plus 3n 3 over 4 and 4 all over 1 plus 5 over n 4. Right? And we know that n over here approaches infinity. So we can cancel this, simplify this. It's equal to 2. So since the 2 is a positive real number, right, we know that a sub n and b sub n have the same convergence divergence. And b sub n is this one. 1 over, let's put it here, 1 over 3 halves. And with this, we can already say that um, this is converging. Specifically, we use the p-test. What the p-test says basically is that for anything that's 1 over n raised to x, as long x, which is here 3 halves, is greater than 1, it is converging, equals converging already. But anything that's less than 1 is diverging. Does it make sense? As n approaches infinity, since the exponent is more than 1, as n approaches infinity, it will become 0. This will become 0 as n approaches infinity, so that's why it's converging. Alright. Yeah, question 5. Alright. This one. For this, we can already see that there's a cosine n. And when there's a cosine n, it usually means you have to squeeze theorem it immediately. So cosine n, absolute sine of cosine n, absolute value. And then we know it's cosine n is only from negative 1 to 1, but since it's absolute value, it's only from 0 to 1. Then you can remove the absolute value here, because cosine n is only from 0 to 1. There we go. Okay. So now we have this numerator. We have to make the numerator into this. We have to integrate the numerator into our squeeze theorem here. So it becomes 2 3n is 2 3n plus cosine n here, and 2 3n plus 1. And with this, we can already, we can kind of already find out if it's converging or diverging. Because, actually, no. And we can just do this, 5n. Yeah, let's do it here. 5n. through this, we can already kind of find out if it's convergent or divergent because of the comparison test. So it's not the limit comparison test, but the comparison test. So basically, what the comparison test says is that if we have these greater than or equal to, we can find the, the convergence or divergence of the ones on its sides. So either this or this to find if the middle one is converging or diverging. But there's something to note here is that okay, wait, I have to double check it just to know that it's right. But okay. So there's something to note that is that, for example, this one we use the left one because the left one is easy. The left one is a simpler thing to find out. But if you're using the left side, so whatever is less than the actual function, we can only tell that if it's diverging. We can only use it here if it's diverging, and here if it's converging. So what this means is that if we check the left, we check the left function, and we find out that it's diverging, then that means this is divergent. But if we use the left one and we find that it's converging, it's inconclusive for the center function. So it doesn't matter that if it's if it's diverging or converging. The function on the left than of the main function, we can only find if it's diverging, and on the right side we can only find out if it's converging. So all right, so let's use the 2, 3, n over 5n since it's a simpler function to use. All right, okay. All right, okay. So we can basically do this. This is equal to 8 over n over 5 over n. 8 over n over 5 over n. All right. Wait. Okay. Wait. Okay. 5 over n. Okay. Wait. Over 5n. Okay. All right. 5 over n. Okay. Okay. And this equals to 8 over 5 n. Okay. So it becomes 8 over 5 n here. And since 8 over 5 n, this is to be specific, this is a geometric series. This is a geometric series. So that means it's r raised to n. And if the r, the ratio, whatever the ratio is, 8 over 5, if the r is greater than 1, the series diverges. If the r is less than 1, the series converges. So since the r here is greater than 1, so since 8 over 5 is greater than 1, the series diverges. Right. So consider the power series, determine whether the series obtained when x equals 0 is absolute convergent, condition convergent, or divergent. So when they're asking for absolute convergence, if they're asking for absolute convergence, we have to do two things. We have to first find if the function itself, if the series itself is convergent, and we also have to find if the absolute value of the series is convergent also. Yeah. We also have to find if the absolute value of the series is convergent. So let's start with the normal one first. So over here, so with this, something we can do is to first, alright, something we can do first is to, okay, first you have to find out if it is ultimately decreasing, right? And to find if it's ultimately decreasing, we have to find, wait, I just have to confirm it. So first of all, it says here, when x equals 0, it determine when whether the series obtained when x equals 0. So first we just simplify this when x equals 0. This becomes negative 3 and yeah, 3n over square root of n, right? And with negative numbers, you're not allowed to put negative 3n here. You could separate the two. It's negative 1n here. 3n all over 3n square root of n. And we can see here, cancel, cancel. So the simplified is here, negative 1 n over square root of n. And now with this, we have to find out if the series is ultimately decreasing. And what ultimately decreasing basically just means is that the absolute value of this is decreasing or not. So absolute value of this is just absolute value of this is just 1 over square root of n. And 1 over square root of n we know is ultimately decreasing because as the limit approaches n over infinity goes infinity, 1 square root of n is equal to 0. So this means this is ultimately decreasing. And since it's ultimately decreasing, we can now use the alternating series as AST. And basically, we use AST if there is a negative number, if there's a negative 1 raised to n. So, alright, so we use AST. And for alternating series test, it says this way. Here we go. Oops. Any series, negative 1 raised to n, b sub n. So our b sub n here is the 1 over square root of n. If b sub n approaches 0, then the series converges, right? And we know that b sub n does we know that b sub n does approach 0 because here and then b sub n equals 0. So we know by alternating series test that the entire function, whatever the entire series, this one, 3 n squared of n when x is when x equals 0, when x equals 0 converges, converges. So this is so this converges by AST. But but after that, you also have to find whether the absolute value, whether the absolute value converges or diverges. Right. So, ayan, this one. So over here, okay, let's do it here. Yeah, let's do it here. I'll just add it here. All right. So it's the exact same thing. So we can skip to here. This one, -1n. So -1n over square root of n. Right. But the only difference now is that it's an absolute value. And since it's an absolute value, we actually cancel out the 1 now. It's the, the final simplified series is 1 over square root of n here. And with 1 over square root of n, we can use the p-test again here. So this is equal to 1 over n 1 half, which 1 half is less than 1. Therefore, this one, the absolute value of the series, let's just say of the series here, is divergent. And when one of them is divergent, the other one is convergent, we can conclude at the very end is that the series is conditionally convergent. Convergent. There we go. All right. Okay. Next is to determine the radius. Okay. Find out the radius and interval of convergence. We have to either use the ratio test or the root test. So for now, we'll use the ratio test, which is basically absolute value of a sub n plus 1 all over a sub n is yeah is equal if okay all right. So if a sub n plus 1 is equal to 0 to 1, 0 to 1, 0 to 1, 0 to 1, then it is absolutely convergent. Absolutely convergent. Absolutely convergent. If it is greater than 1 or infinity, if it's greater than 1 or infinity, then it is divergent. And then if it is equal to 1, it is inconclusive. Inconclusive. Alright. So let us go back to this one. 2x minus 3n. 2x minus 3n. over here, a sub n plus 1, so we used to this, 2x minus 3 n plus 1 all over 3 n plus 1 squared of n plus 1. I'll just skip ahead and just flip it already. So it's 3n squared of n over 2x minus 3. Alright, you can simplify this equal to, this cancels out to the plus 1 only. So this is 2x minus 3. Cancels, so it's 3. And then this is times square root of n over square root of n plus 1. Alright. So now with this, at x equals 0, okay, alright, okay. And this one, we can simplify this one, because this one becomes equals to square root of n over n plus 1. And as n approaches infinity, this just equates to 1. So this is our final, so our final simplified series is 2x minus 3 all over 3. And don't forget its absolute value, because that is what ratio does, is absolute value. So now, since it's asking for its interval of convergence over here, you basically want what numbers will make it from, alright, you basically want what numbers makes it less than 1. Less than 1. There we go, from less than 1. So with this, you can just transpose everything. Plus minus 3, less than 3. Absolute value, remove the absolute value, we just 3, negative 3 here, plus 3, so 0, 2x, 0, x. So this is our radius of convergence, or ROC, is equal to 0, 3. And then now we just have to check when x is 0, x is 3, if it is convergent or divergent, to find out if 0 and 3 is included or not. We know from our number 5, we know when x equals 0, it is convergent. When x equals 0, it's convergent. Oh, no, wait. Since it's absolute value here. Since absolute value here, when x equals 0, it is divergent here. So we know that 0 is not included in the radius of convergence. So it is not included here. And now we just have to check for when x equals 3. So when x equals 3, we use this one, this one. So that's 3. There we go. When x equals 3, when x equals 3, 6, 3n, 3n, all over 3n, square root of n, cancels, equals to 1 over square root of n. And we know 1 over square root of n, this is equal to n1/2 less than 1 equals to divergent. So this is also not included. ROC is this. Ay, joke lang. Okay, alright, my bad. But it's when you're trying to verify. Okay, I didn't realize categorize this. But when you're trying to verify whether the radius is included or not, we use the normal function. We don't use the absolute function. So over here, we just use the normal 2x minus 3, and if we did it normally, we knew it was converging here. So 0 is actually included here. My bad, my bad. There we go. 0 to here. Determine the radius. The radius, sorry, this one is interval. Alright, I'll just clean it up. This one is interval of convergence. For the radius of convergence, it's just find the center of the interval. So this 3/2. There we go. Alright. So just to note, to find out if we include the bounds of the interval, we have to use the original. We have to find if it's convergent or divergent of the original function. Next, this one. Alright. Find the power series representation of this function. Alright. So for this one, there's a given formula for it. To get the power series, it's like 1 over 1 minus x is equal to the sum of 0 to infinity of x raised to n. This is the formula for it. So we want to try to make this function into this function. So to do that, we can do one thing. We can do the first thing, which is to separate the numerator and denominator. So 4x7 times 1 plus 1 plus x8. Right? And to make this minus, this is equal to just 1 over 1 minus negative x raised to 8. So this means that this, if we put it into this form, it is equal to summation 0 positive infinity of negative x, negatives on the outside, x raised to 8. X raised to 8 n. X raised to 8 n. So right now on the outside, we have the 4x7. Negative 4x7. We have negative 4x raised to 7. So what we want from here now is to combine the negative 4x7 into the series. And to do that, we can combine x7 here and x8n. So if we combine the negative 4 sum of x8n plus 7, x raised to 7, x raised to 8n, they're all x's, and you can just add them together. So it's 8n plus 7. And then we can also, and then we also, to add this, to add the left side, we can just put it down here. Negative, it's just 4 times negative 1 raised to n x8n plus 7. So this is the power series representation of the function. This is it already. Let's not forget the 0 to plus infinity here. But that is the power series representation. Alright. So also ask for about 0 and specify its interval of convergence. So to find the interval of convergence, we should to find the interval of convergence, there's something else that we should know about the power series over here. I'll use a different color so it's easier to see. But something to add on to this part over here is that with this, we also know that this one, the negative x over here, the x over here, the absolute value of the x should be less than 1. Yeah, the absolute value of x here should be negative 1. less than 1. So knowing that over here, here, this one, over here, and this one, negative x 8. So we know that negative x 8 will be less than 1, which basically just translates to negative x 8 here less than 1, x is less than 1. So we know now that x, the absolute value of x, yeah, absolute value of x basically is less than 1. And so that is what our interval of convergence is. Yeah, and that what is what our interval of convergence is. X is less than 1. And then now, this one. Okay. So now this one has to find the power series representation of 1 plus x. So this one is, there's no real technique to it. It's mostly, it's either, actually, it's most likely going to be a derivative. But if we derive this, ln 1 plus x of 8, so ln 1 plus x 8, if we derive this, it becomes 8x7 over 1 plus x 8, x raised to 8. And then with this, we can do the same thing as we did before, which becomes just 8x7 summation 1 over, wait, negative x 8n basically equates to negative 1 n times 8 times x 8n, 8n plus 8, right? So, 8. I, oh my bad, it's not 8x plus 7. That's not 8n plus 8, it's 8n plus 7. There we go. 8n plus 7. And as we know from and this one, looks very similar just by a factor of 2. So with that, we can just put the 2 on the outside here. So summation of negative 1 n times 4 times x 8 n plus 7. So if we line these two up properly, it's basically just saying that the derivative of ln 1 plus x 8, yeah, sorry, it's parenthesis here, is equal to this one, which is just equal to 4x7 1 plus x 8. 4, 4x7 1 plus x 8, 1 plus x 8, and then we just put a over 2 here, and then yeah, over 2 here, so that, yeah, we know it's this one now. So then, to find what the power series representation of the actual 1 ln 1 plus x 8 is, we have to integrate this. Integrate this. Actually, we can just do this way. We can just remove the 2 here, times 2 here. This times 2 here, so it's 8. Yeah, okay. So now we just have to integrate this one, which is just this one, which is equal to this one. We're going to be using this one. Negative 1 n times 8 times x 8 n plus 7. We're going to be integrating this. And integrating that will give us so it's like it's all over x x 8 and plus 8 up into its plus 1 is plus 8 here over 8 and plus 8 here 8 and plus 8. And since integrating only affects the x values, so it's just times 8 negative 1 and cancels 1 and plus 1. So yep, okay. It all equates to negative 1 and times x times x all over 1 and plus 1. Oh, x 8 and plus 8. There you go. Plus v. Not by the plus d integrating. Yep. Okay. And now that we have that, we have to then find, we have to find what is c. So to find what is c, we just, when x equals 0, the entire thing is equal to 0. It also equates to 0, so that means c equals 0 here. It's easy to find the c, you just have to make x equals 0 because it will equate everything to 0. And you can find out what c actually is. So we know that c equals 0, so this is our final thing, our final equation. 1 and times f 8 and plus 8, 1 and plus 1. There we go. Alright. Okay, this one's the longest one, Taylor degrees, Taylor polynomials. Alright, this question itself is not too difficult, but Taylor series in general is a difficult topic. So let us do this. So find the third degree Taylor polynomial f of x equals x raised to 5/3 about 8, and use it to approximate 8.35 thirds. Write your answer as a single fraction. Alright. So Taylor series is okay. The way Taylor series works is p of x is equal to f and derivative and yeah, the third the blank degree Taylor polynomial is equal to the blank f derivative of 0 of 0 of 0 all over n factorial x minus a. Alright. And then a is just about 8, so a equals 8 here. So it's x minus 8 over here. So basically, this is what we're trying to find. So since it's a third degree Taylor polynomial, so we're basically looking for the third Taylor degree here. Alright. So the most the safest way to actually solve this problem is that we have to basically add all of the previous derivatives. So we'll start basically from f, basically f0 of x, then f0 of x, f1 of x, the first derivative of x, second derivative, and finally the third derivative, right? So since we know that it's x5 over 3, we just find this one's x5 over 3. Derivative here is 5 over 3 x 2/3 5 over 3 times 2 over 3 times negative 1/3 and then 5 over 3 2 over 3 negative 1 over 3 times x negative 4 over 3. So these are our derivatives. And we basically have to also find what their f of the quote-unquote f of 0 is. But since it's about 8, our 0 now becomes 8 over here, right? Because it's about 8. So basically, we just have to now find what the f of 8s are. So here, 8, it's 8, 5/3. 8 is 8 is equal to 2/3, so it's 2 5/3. 2/3, 5/3 cancels. Put 2 over 5, 2 fives. This one, 8 was 5/3 times 2 raised to 2. This one's equal to 5/3, 2/3, 5/3, 2/3, and then 2 equals to 2, 1/2. And this one is equal to 5/3, basically 5/3, 2/3, 1/3, negative 1/3 times 8, 1 over, negative 1 over, wait, 8, negative 4 over 3 becomes 1 over 8. 1 over 3 equals to 1 over 2 raised to 4. Alright, equals to 1 over 2 raised to 4. Alright. And now we basically just have to add all of these. All of these. You have to add all of these and make sure to remember the n factorial over here. So I'll put a new frame. So first of all, it's 2 raised to 5, so 32. Oh, sorry, 32 here. Over, since it's the zero derivative versus the factorial, it's just zero factorial is just 1. Apparently, zero factorial is just 1. 32. That's 32. Plus 2, 4, 20 over 3. 20 over 3 all over 1 also. But remember, over here then, x minus a raised to n. X minus a raised to n. So it is a x minus 8 over here. Plus this one, 10 over up. 5 over 9. 5 over 9. X minus 8 squared. This one, 5 over, this one's like 5 over 27 times 1 over 8. 5 over 21, 5 to 2, 1 6. 5 over 2, 1 6. X minus 8 cubed. Yeah. Alright, yeah, there's that. And then this is our this is our working equation. Our working equation to approximate 8.3. We just substitute it in, and 8.3 minus 8 is 0.3, which is 3 times. So let's just put it here. 32 plus 20 over 3, 3 times 3 times plus 5 over 9, 3 times squared plus 5 over 216, 3 times cubed. Then we have to add all of these. I'm pretty sure calculators aren't allowed in the final exam. So 32 plus plus 900 cancel 1 over 20 plus 927 and 231,200,8, which is 8 plus 1 over 1600. There we go. 8 times. Oh, I forgot. I also forgot. But 3 factorial. 3 factorial. Um, so here divided by 2 factorial. So it's 40. Alright. 40 over here. 40 over here. And then 3 factorial 6. 0, 0 to 9,200. Yeah, 9,200. Add them all together. It's, if you add them all together, 49,200, 34. 9, 4, wait, no, sorry. That's 230. So it's 34 plus 1 over 200. No, not 230. My bad. Such a big number right now. Times 6, 9,600. Yeah, 9,600. Alright, okay. And then, okay. It's all over 9,600 plus 1 plus 2, 4, 24, 140 times 24. 24. So, final answer after all of that is 326,641 all over 9,600. This one's their final answer. Okay, yeah. 326, 641. And that is the third, that is the approximation of 8.3 if after using the later series. Alright, we're almost done. Last part. Alright, so this one is multiple choice. Alright, so these ones are multiple choice. So this one first. Actually, wait, I think, okay, we can answer the first two first. First two are pretty easy to just look at. So for the series -1n, if sk is the k partial sum of the series, what is the value of sk s7? So this one should be intuitive naman. So S8 is the 8 partial sum. So basically, it's S8 plus S7 plus S6 plus blah blah blah, right? And S7 is the same, so S7 plus S6 blah blah blah. So just minus these two together, we get S8. So whatever S8 is. So that n equals to 8. So negative 1 raised to 8, since it's an even, this cancels out to just 1. 8 over 8 plus 1, 72. 1 over 7. This one, if A of n is divergent, the series of A of n is divergent, which I found is not necessarily divergent. Alright, so something to note about here is that um, the functions that that follow the same pattern are functions that either add like a constant, plus 1 over 2 n is this one is basically 0 as n approaches infinity here. So this is doesn't count. So there's basically just a sub n. This one is also the same because absolute value shouldn't does not change the type of series as it approaches infinity also. 22a, it also doesn't change because 22 is just a factor. It's just you can literally just put it outside and it's the same. It's the same function, so it's still divergent. But for NaN, n could be n does the n affects a sub n because it doesn't it does not equate to 0 at the very end. Yeah, it does not equate to 0 at the very end as n approaches infinity. So it does actually affect the convergency or non-convergency of the function. Finally, this one. Okay, this one is also a application of Taylor series. So we'll need to work on this one as well. There we go. Alright, last question, guys. Okay. So for this one, so for this one, what is the 2023rd derivative? This is basically what is the 2023rd derivative when x equals 3. Alright, so, okay, so we can do it something. Okay, so first of all, this is a little bit of an imagination as well. But when you derive this function, the only thing that really changes is this one because it's x. So your d over dx. So these are just technically constants. So you don't have to touch those when you're deriving. So every time you derive it, you can break this down. So it's 2n plus 1. And since it's yeah, yeah. So every time you since you're deriving it x amount of times, it'll become something like 2n plus 1 times 2n plus 2n minus 1. Oh, sorry, times. So basically, this is 2n factorial. So 2n factorial is just the derivative of x minus 3, x minus 3, 2n plus 1, yeah, 2n plus 1, 2n plus 1, 2n plus 1, 2n plus 1. Alright. So this is what is basically the meat of the equation. So the 2n plus 1 factorial is equal to the 2n plus 1 derivative of x minus 3. And since we're looking for the 2023rd derivative over here, we're looking for the 2023rd, right? So basically 2n plus 1 is equal to 2023 over here. This is where I'm getting it from. 2n plus 1. So 2022 and is equal to 1011. Then we just put it back into here, 1011. So So n is 1011. Over here, negative 1, 1012. X minus 3, 2023. 3033 factorial. Let's count it out because it's an even exponent. Cancels out. X minus 3, 2023, 3033 exclamation point. And we're looking for when it is x equals 3. So 3 is over here. Okay. When 3 is over here. So what that wait, okay. Yeah, okay. It is wait, okay. We don't put it here first, but it is x minus 3, 2023. So this is just equal to this, right? Is equal to this. This part is equal to this. So we still have to find the 2023rd derivative. And it's a bit confusing, but when we use the derivative Taylor series to find what n is, and then with n we can change this function into basically just this. Then we have to derive it 2023 times again. But this one's much simpler because 2023 times is just 2023 factorial. X minus 3, 0. By 2023 times, this becomes the 0 basically. All over 3033. So when x equals 3, it's basically equals to 1. So 2023 over 3033. That's the formula. And that is the this problem set. This is to be specific. This one is the in ring box. This is second long exam for midterm AY 22-23, August 2020. So this is it. This is everything. If you have any questions, feel free to ask them now. Yeah, while we wrap up this session. Since mukhang wala nang tanong, that's it for our Math 22 review.